The authors acknowledge that this podcast was recorded on the traditional, unceded lands of the Lekwungen peoples. Hello, and welcome back to Stories from Space. I'm your host, Matt Williams, and joining me today is Ryan Sprenger, the Senior Research Physiologist at Fauna Bio, a Berkeley, California-based medical research firm. He's a former postdoctoral research fellow at the University of Wisconsin in Madison, and a specialist in cardiovascular and pulmonary physiology. Dr. Sprenger, welcome to the show.
Oh, thank you so much for having me. Excited to be here.
No problem. Thank you. And now today, what we are really going to get into is your concept, a revolutionary concept, which is known as the Studying Torpor in Animals for Space Health in Humans experiment, or STASH. And this was recently selected by NASA's Innovative Advanced Concepts program for Phase 1 development. So before we get into all that, which promises to be very cool, can you tell us a little bit about how you got to this place now? What was the road like that brought you here?
Yeah, certainly a maybe serendipitous or fortuitous road, certainly for me. But I started, so early on in my research career, I started in comparative physiology, cardiovascular pulmonary work, and primarily the animals that I was working in were hibernating species. That was my general interest to begin with. And so throughout my undergrad and master's research, I worked in sort of what we would call the mecca of hibernation research in the United States. And that's where the 13-line ground squirrel, a very commonly used hibernating model, was often experimented on in Wisconsin in the States. And so I was surrounded by a lot of hibernation physiologists and biologists, and I grew an interest in that. And early on in my hibernation research career, I became very interested in any mitigative effects that hibernation might serve for space flight and space exploration. It was something that I think, like many of us do, I look up into the stars and think, how can I make an impact? So that interest grew through my early research career and really started to peak and flourish when I went to UBC. For my doctoral research, I was in William Milsom's lab, and a former postdoc in his lab, you might know this name, Jessica Meir. I met her on occasion, and really a truly inspiring person who was making an impact in the space field. And so it just grew my interest in how hibernation might help spaceflight. And so as my career progressed, I met a lot of people and talked with a lot of other hibernation physiologists and biologists about these types of questions and grew a network. And then when I arrived at Fauna Bio, myself and Mark Betker, another person listed on the grant as a co-PI, we got together and started to come up with ideas on how we might actually be able to study hibernation in space, which hasn't occurred yet. It's the capability is just not there. And so our first step was, well, then let's make the capability. How do we do this? How do we get to the point where we can study hibernation in space? And that's where STASH was born.
Now, looking at the concept, it's really quite interesting. But what really surprised me was, now you guys developed this because, in fact, there's been I think it'd be more accurate to say there's been no research so far in terms of hibernation in space. Is that correct?
Yeah, that's how I would describe it as well. And a few key words on that is in space. There's certainly predictive experiments that we can run on the ground to start to understand, maybe do these animals have protections against things that you might run into space. But precisely so, there's been no examination in hibernation in space specifically.
And in fact, yeah. I was actually surprised to hear that, at least initially, because I know NASA has been looking into this for many years, ever since they announced their Journey to Mars plans. This was an idea that was on the books, and they've done work with SpaceWorks. I can recall reporting on that many years ago. And yeah, and the idea being, of course, this may very well be necessary for deep space missions, long duration transits. So can you tell us, for my listeners, why is this technology considered so very, very important for missions to Mars and, of course, beyond?
Yeah. I think really what it helps out with, or what it's critical for, is trying to find ways to protect human health in space. As I'm sure your listeners know, and as you know, that space is a very harsh environment. And so I think NASA has a RIDGE acronym that they use for the different hazards of space. And if I'm remembering the RIDGE acronym correctly, it's radiation, isolation, distance from Earth, gravity fields. That's a really big one, obviously. And then hostile environments, I think, is their last. And hibernation itself might provide answers to almost every part of that acronym. I mean, there seems to be precedence for radiation protection or radio protection in these hibernating species. And that's actually something that's being well examined on the ground right now. But again, as more of a prediction rather than an actual examination, because we can't mimic cosmic radiation precisely. As a matter of fact, we're actually looking into that ourselves, myself and Mark Betker, in collaboration with Mike Weil at Colorado State. We're using simulated cosmic radiation to try to understand if these animals have protections against low chronic doses like we would see in space. But that's all to say that there is precedence for these animals having radio protection. And that goes back to I think 58 is when they started, maybe even earlier, 51. I think it was Smith in 51 and Cuskin in 59, Saccia in 68. These are all scientists, hibernation biologists that have looked at this specific question. Do they have protections against radiation? And it appears they do. There's another collaborator I have, Matteo Suri in Italy. He's done a more recent examination of synthetic torpor. So this is a torpor that's been induced in an animal that doesn't normally go into torpor. And even then, they show some signs of radio protection. And so hibernation certainly might provide protections against radiation, the radiation damage that you get in space. Isolation, if you're able to reduce activity in humans, you can sort of get rid of that feeling of isolation. So they're for example, if you see in the movies, maybe a pod or something like that, where they're in a suspended state and not really perceiving isolation. And that I think applies to the distance from Earth as well. And then gravity fields, this is another hot topic of research, particularly with hibernation, because these species appear to show protections against disuse atrophy, and that's both bone and muscle. And so these animals, for example, they're completely immobile for up to 9 months in some species, with some exceptions during the hibernation period, but they're not using their muscles and they're not using their bones, and they're not loading their bones, I should say. And if, for example, you do that in a human, you lose muscle like crazy. It goes away quite quickly. It's disuse atrophy is a problem. And it's certainly a problem in space. And I know that astronauts spend a lot of time exercising to help mitigate this. But it seems that hibernation might provide tools or pathways that we can tap into to help mitigate these issues that you have in space. And so it really seems like hibernation might be a great catch-all for a lot of the problems that humans have in space. Now, in my mind, the other option is to get to where you're going faster. You can also reduce time in space that way, but I think there's limits at that as well.
In fact, yes, in terms of what hibernation is good for there, yeah, it does put me in mind there are several classical examples from science fiction. And one that comes to mind right now when you mentioned isolation was Aliens, where at the very end, little Newt is saying to Ripley, so we're going to sleep all the way home? And then, of course, they go down for their repose, and the music is all nice and gentle and calm. And in fact, yes, this is part of it. It's that one of the greatest challenges with long-duration spaceflight. How do we keep a crew provided for the supplies? How do we deal with all the waste they're going to generate, not just human waste, but all packaging and so forth? And ultimately, how do we keep them from going crazy and turning on each other? Because, yeah, an Orion spacecraft or any other kind of transfer habitat that's on the books right now, they're pretty cramped when all was said and done. Yeah.
Yeah.
So yes, yeah, that of course is the main thing. I was interested to learn that in fact it could mitigate radiation exposure. Now, can you describe for us the stash experiment? What exactly does it look like? Because I remember reporting on it and I thought, oh, that's quite neat. But yeah, give us a little rundown on how it works.
Yeah. So the stash experiment as a whole is, we designed it in 3 phases, more or less, to mirror the NIAC progression. The first phase being, generally speaking, proof of concept and conceptual design of the unit, which we are quite far along on already. And then this building a prototype and testing and making sure that it actually works and measures the physiology we want to measure. And the second phase being testing the unit, or more or less making a flight-worthy unit, and then testing the unit on the ISS to make sure that it, again, is measuring the things that we want it to measure. And the third phase is again, the most scientifically interesting phase, and that's actually putting a hibernating animal in space. And for the first time understanding questions like, does a hibernator go into hibernation in space? Does it still show muscle atrophy and disuse atrophy protections? Does it show protections against radiation? And so that's the phases of the experiment. And so what we've had to do initially with the proof of concept and design is basically make a unit that allows us to hibernate an animal in space. And as you might be able to guess, what you have to do to hibernate an animal in general is you have to make it cold and you have to take its food away. That's the two main things. Now, there are species that want to hibernate so bad that you could keep it warm and keep its food by it, and it'll still go into hibernation. And that might be a useful tool in this endeavor. But that's precisely it, is firstly making a unit that's capable of getting an animal into hibernation in space and being able to measure physiology and phenotypes that you might see in space to answer the questions like, is the animal hibernating, and et cetera. And so that's what STASH is really designed to do as it progresses.
Now, in terms of the layout of it, or the mock-up, there was a nice handy illustration there provided in your proposal. And so you've got two animal chambers, so two rodents would be inside these, and you've got infrared cameras watching them, a thermal shield to make sure the chambers are nice and cooled, and then a whole bunch of sensors that are recording their vitals.
Yeah.
So to clarify, while they're in the chamber there, you're gradually lowering the temperature on them to induce a state of torpor, and then seeing how they do.
Yeah. Correct? Yeah. The engineering of this project has actually been quite a bit of fun. I've dabbled myself in the past in designing these types of equipment, not necessarily meant for space, but meant to measure physiology. And so being able to entangle these physiological measurements with something that would work in space has been a lot of fun. So, and you're precisely right. Two animals we've designed for, and this is if we were to send, for example, a 13-line ground squirrel, that's about the space that we have in the unit. We are space limited in the sense that we're partnering with BioServe Space Technologies, and specifically Tobias Netterweiser at Boulder. And together we're integrating the unit that we've designed into the SABLE unit, the Space Automated Biological Laboratory unit, which is already on the ISS. Several of those units are on the ISS. And so that provides us the opportunity to more or less refrigerate the animals. That's how you cool these animals on the ground, for example. And so we've got a refrigerating unit that can very precisely change environmental temperature. And so being able to fit two animal enclosures into this SABLE unit within the STASH unit allows us the opportunity to measure, like you're saying, a lot of different things. We can get things like total ventilation using pressure sensors. We can get things like metabolic rate, oxygen consumption, and CO2 production with CO2 and O2 sensors. We've got infrared camera to monitor the animal's activity. We can also implant the animals with telemeters that allow us to measure things like heart rate, blood pressure, and activity as well. And so we can grab as much physiology as we can possibly fit as far as sensors onto this unit, which I think is important to the study because, like we were saying, we only can send two animals at a time if we were sending one unit. So we've got to grab as much as we can from each of these animals. And so, yeah, and thermal shield to make sure the animals are maintained at a temperature that we're happy with because these electronics produce heat. I think in that diagram, we've also factored in data acquisition boxes so that we can digitalize the voltage signals from these sensors. So it allows us to real-time monitor these animals and know exactly when they're in hibernation and for how long.
Yeah. And of course, I want to emphasize this. This is all done slowly, gradually, carefully, so that the animals are safe. And yeah.
Oh, absolutely. By all the ethics committees, which we interact with quite frequently, these animals are kept. They're very precious animals to us. So we keep them as safe as we possibly can. Yeah, absolutely.
Yeah, must emphasize that there because, of course,
definitely
the mention of animal testing in space. But of course, yeah, and with the data from this, I mean, eventually the idea is to do human trials, I would imagine.
Yeah, we would like to. I mean, and it's hard to say exactly where the data go, and we hope that it goes positively, but, as science is, we don't necessarily know exactly yet. But that is the hope one day. We hope that we can ascertain some information from this that will help us either produce some sort of targeted mimetic that allows us to induce hibernation in humans, or to at least find mimetics that help with the radio protection or something like that. So yeah, the end goal is really not just purely academic, but it also is, as our title in STASH suggests, we really hope to help humans with this. We hope to mitigate some of these effects. And this is something that's not been that's not been mitigated yet with planned long duration flights on the upcoming schedule. There certainly is a danger for the astronauts as they progress in that long duration flight. So we're hoping that we can help with that. We hope we can help humans. Certainly a tough thing to have to do and talk about with regard to having animals help us with this, but sometimes a necessary thing, certainly. Yeah.
Yep. And of course, the caveats and addendums. Cruelty-free
The
and
caveats and
been
addendums.
approved. Yeah. Yeah.
Yes.
And
Yep.
now, in terms of this research, there are likely to be applications for here on Earth too, as I would imagine, because, and this is, I wish I'd mentioned this sooner, but this is in fact a growing field in biotechnology, isn't it? Studying,
Mhm.
as you guys said in your proposal, the phenotype of hibernating animals for human health applications. And
Mhm.
so, in terms of applications here on Earth, what kind of things could we see coming from this?
Yeah, you're precisely right about this, and I'm glad you did bring it up. I think it's a really interesting and very important facet to this type of research is, again, we're looking at these questions in a very extreme environment. And what it does is it provides a novel way to look at some of these questions that we still run into here on Earth. And, the radiation type is different, but it still might provide some answers to how these animals are protecting themselves from radiation, which also could be used potentially to protect humans against radiation on Earth as well. But I think a really important one for this, and something that certainly Fauna Bio is interested in as a company, and we are as well, is, with a new novel environment in which you're studying things like disuse atrophy, bone atrophy, and these circumstances in which muscle metabolism has changed or must be altered to protect these tissues. These are hot topics on Earth. Muscle metabolism in the field of obesity, for example, is very important to understand with trying to drop mass, but not dropping muscle mass, for example. But preserving muscle mass and bone mass in situations where you have disuse atrophy in humans, it is very important to study. And again, providing a novel environment in which you can test these questions, I think is going to be really key to helping, again, not only humans in space, but humans on the ground. And the way we designed this unit was not to be specifically just for hibernation. We're hoping to provide a unit that is usable by a lot of different researchers with different questions. We don't necessarily have to cool the unit. You can keep the unit basically any temperature between 4 degrees Celsius and 37. And so you can ask physiological questions in space as well. That's not necessarily hibernation derived, and you can get these answers from this unit as well. So I think we hope it to be a far-reaching way of examining important questions. And that's not even talking about cardiovascular and pulmonary risks. And, the SANS risks, for example, the space-associated neuroocular syndrome. These are other areas that there's not a tremendous understanding about, but we might gain more of an understanding with these types of experiments on the space station. So, what we can pull for that as far as health on Earth is, again, a novel way of looking at it.
So, in fact, if I were to just come right out and ask it, could we be looking at for real cryogenic suspension in the not too distant future for aging humans who want to cheat death, but also for people who are hoping for medical cures for currently untreatable, uncurable diseases? I mean, that is a bit of a sense I get. And that was a huge craze towards the end of the 20th century. So I would say a lot of people are sort of cynical about that idea now, but is that in fact a possibility here?
I've been asked that question a lot, actually, and it's a question I've thought about a lot, and I think a lot of the hibernation researchers have thought about a lot too. And that really is the golden egg. That's the golden apple, is getting humans to hibernate or go into some sort of suspended state, which could have far-reaching effects, like you said, for longevity or even acute traumatic injury. There's a lot of things that hibernation might be able to provide for humans, and that's actually a question that Fauna Bio is asking specifically, not even necessarily related to STACH, but that's a question Fauna Bio is asking specifically, is how do we tap into these extreme animals or animals doing these extreme things to help cure incurable diseases or come up with new targets or new pathways to help with issues that we have on Earth. But to me, obviously my greatest interest is that specifically, can we get a human to hibernate? Can we go into a suspended state? And this is, you're right, this is a question that's been asked for a long time. I think DARPA used to hold symposia in the early 2000s asking that question specifically of the hibernation field. Are we there yet? Or how close are we? And it's hard to put a number on how close we are, but certainly in the last 20 years from the onset of the 21st century, we have come a long ways. I mean, we now have very reliable methods of getting animals that don't normally hibernate, getting them to go into a synthetic torpor state that mimics the hibernation state quite well, and oftentimes is providing protections that we see in the hibernation or hibernating species. So we're moving forward, but are we at the point where we can get a human specifically to hibernate? I certainly wouldn't say that's like a next 5 years thing, but maybe 10, maybe 15. I think we're moving in a really good direction. And really at the end of the day, we're really hoping that Stash will help with that. We're hoping that we can help move that question forward into a usable thing.
Yes. Well, I certainly hope so, because the applications for space exploration alone are very exciting. And this is one of two sort of, how would I describe this? Sort of two avenues of research, it seems, when it comes to deep space missions. It's like, can we get there faster? And if not, what can we do to just cut down on the amount of time the crews actually have to be in a wakeful state, eating, breathing, defecating, so forth, carrying out all these human functions that, of course, take up space and consume resources and produce waste. Yes. And if I were to ask you, and I hate that I always do this, but I always love to ask people, researchers, it's like, putting aside all the cautious optimism, or we don't want to speak too soon on the developments that we're helping here, but in terms of like, what do you like to visualize here? Like, if you're thinking about your work and the potential applications in the future there, what exactly does this look like to you? What do you think that we could be achieving by the time, say, 2040s, 2050s, that missions are going to deep space?
Yeah, well, I think in my mind, again, throwing aside the cautious optimism, I would love to see some sort of suspended state in which humans are able to go into hibernation-like state. I like that facet of the two options of going into deep space travel, because really I think the best case scenario is it's both. You travel faster and you put humans down into a suspended state. What that helps with regard to putting humans into a suspended state, for example, is weight. And like you say, humans have to consume things, and that's weight that has to go up into space. We defecate, we do all these things that are a product of our metabolism. And what hibernation might provide is, with this suspended state comes a reduced metabolism. And so we consume less things, we defecate less, and we consume less oxygen. So there's not as much of a worry on that side. And that's all true from hibernators. They don't defecate during hibernation season. They don't urinate. They don't consume any food. And they don't consume water either. And so in an ideal world, in the maybe not so distant future, I would love to see that specifically. As far as spaceflight is concerned, I would love to see it, or at least help with getting to the point where we can move humans into a hibernation-like state. And we're learning that it doesn't necessarily have to be the exact same as a hibernating ground squirrel, for example, that's going down to a body temperature of 2 degrees Celsius. Bears hibernate as well, and their body temperature is not going nearly that low. And so there seems to be this continuum in which you can fall, and the benefits, they accumulate quite quickly, even if you're early or high up in this hibernation state. And I think, added on to this, personally, I would love to see hibernation continue to provide avenues for human health on Earth. I think there's opportunity there. Hibernators are well protected against ischemia reperfusion. Hibernators are well protected against diabetes. They're well protected against cardiovascular issues. So, these are things that I think we can tap into, again, with these new avenues or new ways of asking these questions, including the Stash unit, so that we can help humans here, but we can also get humans to go further. That's my ideal progression. Yeah.
Excellent. And, well, I hope generation ships might be a potential application someday, because, of course, in terms of the long term, and again, this is something that not just NASA, of course, but futurists of every kind and research institutes, how do we go interstellar, right? Beyond deep space and going to other planets and being interplanetary, how do we go interstellar? And again, it's one of two options there. If you're talking about people, it's either go really fast, or again, hibernate, build ships that can accommodate lots of people and hopefully that they will have that option for going down for reefer sleep, as heard it called.
Yeah.
So yeah, interstellar travel. This too could be a dream at this point, but definitely. Do you ever think that when you're conducting your research, it's like we're actually getting closer to realization of this once fevered dream?
Yeah, yeah, certainly. I think we've all got that starry-eyed, bushy-tailed look into the stars and see how far we can go. And so when you're doing research like this, that's something that you'd at least like to contribute to. And that's where I put myself in a lot of this is, it might be that I'm not involved in the teams that do this or am alive during a time that this happens, but I'd like to think that we're at least helping progress that forward and providing the basic knowledge that we're going to need to maybe one day do that. Yeah, absolutely. Yeah.
Yeah. And of course, this is a question that comes up a lot, I've found, in science communication. And I'm wondering if people like yourself on the research end, if you're ever subjected to this, whenever it seems the subject of humans getting out into space, the migration to space, greater exploration, or even, or especially human settlement on other planets and such, there's pushback from people who
Mhm.
would say, "Oh, this is distracting from our problems here. Shouldn't we deal with our problems here first?" Is that something you've encountered there in your work?
Well, yeah, certainly. What I should say is this type of question is certainly have been with regard to the hibernation and interplanetary travel and helping, one helping the other. It's certainly something that has come up and when you look at space agencies as a whole, there certainly is interest, but it's not as much interest as other things. And I think that's sort of reflecting that general feeling of, why not just make a better home or clean up our home rather than trying to go to different planets. And I think, for me, I don't think one distracts from the other. I think they could potentially inform on each other. Helping clean up the Earth here might help us prep a planet for interplanetary settlement. And so, in my mind, I think there's benefit to come from both. And so, but in a limited resource environment, maybe that's not the case. I'm biased, of course. I think interplanetary travel and settlement is, I think, important for the progression of the human species. But again, we're talking pretty far out. I don't think we're there yet.
Well, that
Yeah.
is the correct answer. Yes. As far as I've learned that yes, this is definitely the case. It's that
Mhm.
we can do both, and in fact, we may need to do both. One may be very much dependent upon the other.
Mhm.
However, that's a subject for probably a whole another episode.
A debate for
Oh,
another time.
oh yes. In any case, thank you for coming on, and best of luck with your research. And so, final question there. Now that you have been selected by the NASA's Innovative Advanced Concepts, or NIAC program, the
Mhm.
next step will be to build a prototype for testing aboard the ISS.
Yeah, yeah, that's what we see our progression happening. Like I said, I've been thinking about this concept quite a bit. We've been working on this for some time, trying to figure out what are the best ways to do these things with regard to this unit. So, yeah, in phase one, the goal by the end of phase one is to have a working prototype that can show proof of concept in the context of being able to get an animal to go into hibernation in it, for it to measure the physiology that we intend to measure, and for it to integrate with the Sable unit flawlessly, essentially. That's the goal for phase one. And, obviously after that, like I think most other NIAC awardees this year and in other years, the goal is to put ourselves in the best position possible to go for phase two. And that, in phase two, we see ourselves building essentially a flight worthy unit, a unit that's ready to go up. So that's where our progression is at right now, certainly. And I've had a lot of fun with the program so far. The people that I've interacted with, they're really great people, and I'm really excited for the progression of even just phase one, for example, with the orientation meetings and everything, because I get the opportunity to meet a lot of really intelligent people thinking about a lot of really cool questions. And there is a little bit of intimidation in there because if you look at the list of awardees this year, there's not really any looking at any sort of biological questions except for us. So I'll be stepping a little bit out of my comfort zone with regard to physiology and asking the types of questions that might be useful or interesting to the other people on the list. But yeah, very, very excited for the progression of phase one and aiming for phase two.
Well, excellent. And As I said, I wish you the best of luck because this is one
Thank
of
you.
many technologies, especially the selectees for this year, that are so very cool and that I really would like to see
Yeah.
happen. As an insider here, someone who was part of this program in the selectees, the objectives or the priorities really that have been assembled or that sort of become clear from all the people who were selected for development. Yes, they
Hmm.
are. How do we facilitate interplanetary exploration with crewed vehicles? How do we facilitate interstellar exploration? So far, just robotic vehicles. And
Hmm.
what other priorities would you say really showed up this year?
Oh gosh, that's a good question. I think you're right on a lot of the exploratory side. I think there's quite a bit of interest in improving imaging, deep space imaging. I think that's, if I'm remembering correctly, that shows up quite a bit on the list. I think there's even one that I'm really interested in talking with the lead PI on is it was entitled "Detoxifying Mars." It's talking about getting rid of perchlorates. So that's a terraforming type question. So I think there's a good coverage, but I think you hit the nail on the head. I think a lot of the interest is in improving exploration that's not manned, and in improving imaging. So being able to capture these images and study different parts of the universe with more clarity. That's a big interest, and like I said, we're the only ones on that list that are interested in a biological question and a hibernation question to boot. And I think that sort of mirrors NASA's sort of overall goal. I mean, there is still some interest in hibernation type questions, biological type questions, but it's not nearly as high as these other questions. And so there are people working on these types of questions again on the ground. So there remains interest, I think, in hibernation. It's an encouraging interest, but that's how I would describe the list this year, certainly. Yeah.
Excellent. Yeah. Well, thank you very much, and I hope very much that we get a chance to talk in the future. That there are new
Oh, I'd
developments
love to. Yeah.
that include an experiment that goes to the ISS, and hopefully some progress towards the inevitable or desirable human trials and tests. That would be very interesting to see. And
Yeah.
because, of course, yes, Mars, right at this point, NASA is saying that a truly crewed mission, one that goes to Mars and has surface operations for several months or more, and then returns home with all this wonderful science and Martian samples and so forth. That's not likely to
Hmm.
happen until 2040, if that.
Hmm.
And I feel, yeah, there's a bit of a crisis here. We need to whoop ourselves up and try to get there sooner. So yes,
Yeah.
and
I'd love to see
if
it.
in
Yep.
yeah, and if in fact hibernation is necessary, if we can't, or not even advanced propulsion alone, right? But it does seem
Hmm.
like maybe this would be a better, not a either or, but an and sort of thing, you know?
I think so
Yeah.
too. I think these two would service themselves quite nicely. You can go faster with less weight.
Hmm.
So yeah,
Absolutely. Oh,
yeah,
win, win, win.
yeah.
Yes. Well,
Maybe
thank
one
you
day.
so much. Well,
No,
thank you
thank
so
you.
much. And one more time, I only keep repeating this because I can't emphasize it enough. Best of luck and
Thank
wishing
you.
you all the success.
Thank you so much. It's been a joy to talk with you. I've had a lot of fun.
And to my listeners, I want to recommend you check out the Stash proposal, which again is short for Studying Torpor in Animals for Space Health in Humans. You can read about it all on NASA's website. Just simple word search and it will take you there. Be sure to check out some of the other selectees for this year's NIAC program. And tune in the coming weeks as we will once again be talking about some exciting missions that are currently in progress or will be happening in the next few years, as well as concepts like the Hubble tension, panspermia, and the water world hypothesis. In the meantime, thank you for listening. I'm Matt Williams, and this has been Stories from Space.